We're going to start our geometry review, and we're beginning with transformations. So I'm on page 1 here of your packet, and I'm going to go through this as if you remember a lot, and I just need to refresh your memory on how we do all of this, okay? So first, the way this is kind of set up is I'm going to do the left-hand side. I'm going to ask you to pause the video, try the right-hand side, and then I'll show you what the answer is supposed to be, okay? So to begin with, for number 1 and 2, it says write a rule to describe each transformation. So when I look at this, remember there is the pre-image and the image. And the pre-image is the letters that are just normal letters. And then the image, so what happens after we do the transformation, has the apostrophe, okay? So we call that the prime symbol. So the original shape for number 1 is this shape right here, the T, U, R, and S. T prime, the one down here, T prime, U prime, R prime, S prime, that's what happens after we do the transformation. So when I look and I see here, well, what did happen after the transformation? Okay, I can erase this. And if you remember, this worked out very nicely with our patty paper that we used at the beginning of the year. But if I trace out this shape, I can see that that shape, that original shape there, just slid down, okay? So all I need to do is count and see how far did it go. That's called a translation, if you forgot that, okay? So I'm going to count and see to go from T to T prime, okay? And then it'll be the same for every point, every other point as well. So for T prime, from T to T prime, I see I went 1, 2, 3, 4 spaces to the right, and then 1, 2, 3, 4, 5, 6 spaces down. So to describe a rule for that transformation, I'm going to say underneath here, translate 4 units right, and what did I say? 6? 1, 2, 3, 4, 5. Yes, 6 units down. Oops, I forgot to add an S to my units right there. Okay, so pause the video now. You try number 2. All right, so for number 2, you should have gotten for that one, if you go from S to S prime, or if you count from T to T prime, or if you count from U to U prime, those will all be the same, right? That you were to translate 1 unit down and 2 units right. All right. Nice little refresher there on translations, and then they have you actually do a translation for numbers 3 and 4. So I'll do number 3, ask you to pause the video, and then you try number 4. For number 3, it says translate 4 units left and 1 unit down. So I'm going to start with J. I'm going to go 4 units left, so that's 1, 2, 3, 4 units left, right? Or correct? Yes. And then 1 unit down, so 1 unit down, that would put J prime right there. Okay, I'll erase all my little squiggly lines. So there's J prime. And then I'm just going to do that for each one of these. Okay, for I, I'm going to do the same thing. To find I prime, I'm going to go 4 units to the left. So that's 1, 2, 3, 4 units to the left and 1 unit down. That puts I prime right there. Okay, do the same thing for, what letter is that? I believe that's the letter K. I'm looking at this one right here. So again, 4 units to the left. So 1, 2, 3, 4, and then 1 unit down puts that right there. So I'll label that K prime, and then do the same thing for L. Okay, so for L, it's 4 units to the left. 1, 2, 3, 4, and then 1 unit down. And that is L prime. And then just connect all your points. And one thing I want to point out, I should have pointed this out for number 1 and number 2 also, is that you can see my sides are parallel. So after I've moved them, my sides are still parallel with the original shape. Okay. All right, pause the video. Try number 4. So for number 4, let's check your answer now. You should have D prime is right there. E prime is right here. B prime is right there. And the last one is C prime, and it should be right there. So connect your points. Again, our sides should be parallel. It's an easy way to check to see if you did it correctly. And they do all look parallel to me. Yeah. So go ahead and turn to the next page. And we're going to do this the same way. So first come up with the rule. I'll try, you try, and then we'll actually do the transformation. I'll try, you'll try. Okay. So for this first one, it says, describe the transformation. When I see my original shape here in blue, so let me highlight this. Okay. So I've got my original shape here in blue, and then I'm going to go ahead and make the new shape red. And I know this is the new shape because it's got the prime symbol by all the letters. Okay. And I can see that E and E prime are in that same vertical line. D and D prime are in that same vertical line. B and B prime, same thing. And then you guys can all see C and C prime are in the exact same position, right? That's telling me, since they're all in line vertically, that this is a reflection. They got reflected across a horizontal line. And I'm going to do that line in green. So that line that they got reflected across is right there. How do I know it's that line right there that they got reflected across? Because I can count from, I'll start here on the right hand side, from B prime to that line, 1, 2 spaces. From B to that line, 1, 2 spaces, right? I see it's the same number of spaces for E prime and E. I see it's the same number of spaces for D prime and D. Okay, so and of course C stayed right where it was. So that's how I know that that's my line of reflection. That line, remember a horizontal line, we just did this last week, has an equation of y equals a number. What number? Well, it's wherever it crosses the y-axis. Okay, so it crosses the y-axis at 2. So y equals 2 is my line of reflection, and I just have to state that this is actually a reflection. So reflect across the line y equals 2. That would be my answer for this one. All right, pause the video. Go ahead and try number 6. So let's check your answer. For number 6, you should see that this time the points aren't in line vertically. The points are in line across each other horizontally, right? M and M prime you can see right here. K and K prime right here. N and N prime, they don't move at all. It's the same point, which is kind of telling us where our line of reflection is going to go through. And then L and L prime are across from each other horizontally. So my line of reflection, I'll draw it in green again, should have been drawn right here. Okay? And for a vertical line, it's x equals a number, and I can see that that is at -2. So I'm going to say reflect across the line x equals -2. Okay. This time I just want to point out, I said for the translations that all of our sides would be parallel. When we slide a shape around, the side lengths of the new shape and the original shape would be parallel to each other. Is that the case for reflections? No, right? We can see them intersecting when we reflect them across these lines for these first two problems. So, and that's going to be true for all reflections, unless you have, you know, a vertical line or a horizontal line. They would stay vertical or horizontal depending on how you reflected them. But in this case, we see that the lines are actually intersecting when we reflect those. Okay. For these, they give us the shape, they give us the rule or the transformation. We just have to actually do it. The first thing you want to do for a reflection is draw where the line of reflection is. So in this case, for number 7, you know, I'll do this one, and then you'll try number 8. It says y equals 2. Okay, well, gee, that looks familiar. Okay, we know where y equals 2 is. It's right here. So I draw my line of reflection there, and then to draw the image, because this is the pre-image, to draw the image, I need to count how far away is each point from that line of reflection and make sure it's that same distance but on the other side of the line of reflection. So for instance, I'll start here with R. Whoops. R is 1 space away from the line of reflection, but it's below it. I need to move it up here. I need to move it so that it's 1 space above it. And that's what I'll do. And I'll do this in red. So R prime is right there. Okay. U prime and T prime, can you see this? T is 1 space away, but it's above. U is 1 space away, but it's below. So they're just going to flip-flop. So I'll put a point here where T is and label it U prime. I'll put a point here where U is and label it T prime. And then S is the only one we haven't done yet. We can see is in the same spot. So we'll label that S prime. Okay, so now my shape just looks, oh, let's straighten that out. There we go. Like this. Okay, so there's my new shape. Go ahead and pause the video. You try number 8. All right, let's check your answer, see how you did. So the line of reflection is at x equals 3. 1, 2, 3. That's going through the point C. Okay, which means C is going to stay where it is. I mean C prime, sorry, is going to stay where it is. So I'll just go ahead and label that one first. That's C prime. D is 1 point away on the right. Move it so it's 1 point away on the left. Okay, there's D prime. B is 2 spaces away on the left, so move it so it's 2 spaces away on the right. There's B prime. A is also 2 spaces away from that line of reflection on the left. I need to just move it so that it's 2 spaces away on the right. So there's A prime. And then just connect your new points. And it should look something like that. Okay, and we can see how it's a mirror image. Remember when the line of reflection goes through the shape, it kind of looks like a butterfly wings. I don't know if this actually looks like a butterfly, but we'll say it does. All right, go ahead and turn to page 3 now. So for page 3, now we're talking about a new transformation, and I can tell it's a new transformation because I can't just flip that shape, that HIJK shape, down to form the other one because they don't line up vertically. I can't just slide it. It's not the same orientation. The third transformation that we're going to talk about today is rotation. Okay, so I can see that this is a rotation, so I'll put rotate. And we had certain degrees that we would rotate in. If you remember, we would do either 90 degrees, 180 degrees, or 270 degrees. Okay, and I know since this is my original shape, there's no prime symbols there, and that it goes here, that's clockwise. Well, the camera's backwards, so That's clockwise, right? So that is rotate some amount degrees clockwise, and I'll abbreviate that with CW. How many degrees did I go? I went from this upper, let's see if I can get my orientation correct. I went from this upper right quadrant, quadrant 1, down to quadrant 4. So I just moved, oops, 1 quadrant away. That's 90 degrees. Okay, so I went 90 degrees clockwise. If I would have went another quadrant over, that would have been 180 degrees. And if I would have went even one more quadrant over, that would have been the 270 degrees. So go ahead, pause the video, try number 10. All right, let's check your answers. So for number 10, here's my original shape. Okay, here is my new shape. So that new shape is, I mean, take a look, and we'll talk about this here in a second. It is 2 quadrants away. So I know it was a rotate of 180 degrees, right? That's what I showed you on that last video. I mean, on that last problem. And we don't have to say a direction for 180 degree rotations. And here's why. It doesn't matter if you go the direction I showed right here, 2 quadrants away, or if you go this way, you're still 2 quadrants away. So it doesn't matter if you say that they went clockwise or if they went counterclockwise when it's 180 degrees. So we don't have to put it at all. One thing I did forget for both of these, shame on me, is what we were rotating about. Like, what was the fixed point that we rotated around? And that would be the origin for both of these. So about the origin. We rotated both of these about the origin. The origin was the point that stayed fixed. If you guys remember, we did this with the patty paper, and you just put your pencil right at the origin and just spin the patty paper around it. Okay. For this, they have the shape drawn for us, and they gave us the rule. We just have to actually do it. So for number 11, I'll do it first. And actually, I'm just going to do number 12 with you as well, just so you can see a 180 degree rotation and a 90 degree rotation. For 11, it says rotate 180 degrees about the origin. That means the origin is the fixed point. We'll look at that. S is fixed. So I'm just going to put a new point there, and I'm going to put S prime. Okay. The point I'll start with after S, let's start right here. Let's start with V. Okay. So V, for that to go 180 degrees, it's got to go 2 quadrants. Right? It doesn't matter what direction. Notice for 180 degrees, they didn't say a direction. Okay, I'm going to go clockwise. So if I go 180 degrees, well, look at where I'm 1 space down from that x-axis. So I'm in this quadrant here. To go 90 degrees, I would be in this quadrant here, and I would stop right there, 1 space away from the axis, right? But that's only 90 degrees. I need to go all the way up here. That would be 180 degrees. And if you guys remember, when I spin a shape or a line, because this is a line right here, when I spin a line 180 degrees, it actually just continues the line on, right? And this is what I mean. This is V prime. And you can see how this forms a straight line to go between those. Okay, I'm going to do the same thing for U. Okay, U is in this quadrant, 1 space. Look at this, it's 1 space from the corner, right? So to go 90 degrees, it would be right here, 1 space from the corner, but that's only 90 degrees. I need to go 180 degrees. So U prime is going to be right here. So let's put our U prime right there. And then for T, again, let's keep going. First 90 degrees, to show where that would be, and then 180 degrees. So for t to go 90 degrees, it's on the y-axis. If I was, I went clockwise for all the other ones, I'll go clockwise for this one too. 90 degrees would put it right here, so that now it's on this axis, it's on the x-axis, but that's only 90 degrees. I've got to go 180 degrees. And that's why it's going to go right here. It'll end up down here. So there is t prime. Once we have all those new points, just connect them, okay? So you can see how our lines kind of continue to form these nice straight lines. Whoa, let's erase that. And magic of the iPad didn't really help me out there too much. I kind of missed v prime to u prime, but it's close enough, okay? So that's a 180 degree rotation. For a 90 degree rotation for number 12, we're going to go just one quadrant, and it says counterclockwise. So that means point, and it is about the origin, so actually let's start with that. So that means W prime is just going to stay there. So I'll put W prime right there, okay? But to go counterclockwise 90 degrees, here's X. Okay, counterclockwise is this way. So counterclockwise 90 degrees, it was on the y-axis, now it's on the x-axis. That's where X prime will go. So we can label that one X prime. Let's go with Y prime next. So here's Y. Counterclockwise again is this way. Okay. Well, if you notice, it's 2 spaces away from the x-axis. So if I spin it up here, it's got to be 2 spaces away from the y-axis. So that's where I'm going to put it. Label that Y prime. And then finally for Z, to get Z prime, again 90 degrees, it's in this quadrant. I know it has to end up in this quadrant. It is 2 spaces away from the y-axis. So when I rotate that up, it's going to be, look at that, 2 spaces away from the x-axis. Okay. So that is Z prime. I always put a little dash through my Z's so you don't think that it's a 2. But let's go ahead and connect those now. I've got there to there, there to there, there to there, and there to there. Okay? And that, you can tell, went whoop, 90 degrees counterclockwise. Okay? Last page for today. If you look at page 4 now, this is different. Every shape that we have done so far has stayed the same size, right? Now I see 2 different size shapes. I can see Y, and then here's Y prime all the way close to the origin. I can see Z, and then Z prime is scrunched in, right? I can see W, I can see X, but then W prime and X prime, again, they're real close together. They weren't that close together when it was just W and X, but W prime and X prime are real close together. So because I'm changing shapes, okay, there was 2 words that we learned to describe this. They are not congruent shapes anymore. They are similar. And what I want you to do is, to help you remember this, go back and right in the middle of page 3, I want you to put that all of these shapes are congruent. I want you to go back to page 2, and I want you to put all these shapes are the same size too. I want you to put all of these are congruent. Remember, congruent means the same or equal to, right? And then the same thing for page 1. I want you to go back and right in the middle of the page, I want you to write congruent. For a translation, a rotation, and a reflection, the shapes are congruent. But when we get to this last transformation here on page 4, where it is very obvious these aren't the same size anymore, They're not congruent. They are similar shapes. Okay? That's the big difference. So I've got something happening here, right? For number 13, I'll do that one, then you do number 14. But for number 13, the shape shrunk down. Well, that's called a dilation. Okay, so I'm gonna say dilate, and then we've got to figure out what we're dilating by. So I've got all these ordered pairs. Actually, they're not ordered pairs, but I've got all of these points. I'll just look at y first. And I could have picked any point, but I'll look at y. Okay, for y, I can see my ordered pair is over 1, up 1, 2, 3, 4. For y, I've got the ordered pair 1, 4. For y prime, okay, it looks like, you know, I would have to zoom in to see it better, but I know you guys can't zoom in on your papers, so I'll try to look at this like you guys would be. Looks like it's only a quarter of the way over, and then 1 up. A quarter of the way over, and 1 up. So I need to find out how much did I dilate it by. I need to know what my scale factor is. I want you to write this down. Okay, scale factor. Actually, let's put it in a box. And then under that, I want you to put new divided by old. I want the new measurements or the new coordinates divided by the old or the original coordinates. Okay, remember, the ones without the apostrophe, those are the old coordinates. Those are the original, the OGs. The new ones are the ones that have the little prime symbol, that little apostrophe. Okay, so if I were to do that for these y values, that would look like what? That would look like 1/4 divided by 1. Well, what's anything divided by 1? Itself. My scale factor is just 1/4. And to prove that, we could do that for any of the other points. Okay, we could even check the y values here for that y point. I just did the x values, but I could have done the y values. The y values would give me 1 divided by 4. Look at that. Here's the new divided by the old. 1 divided by 4. Gives me the same answer, right? And it will for any of the points. So dilate, that's what we're going to write here for the rule. Dilate with a scale factor. With a scale factor of 1/4. Oh, see, I almost forgot it again about the origin. Okay. You know what? I'll just help you with number 14 also. Okay. We can see that the shapes are different sizes, so we know we're dilating. These are similar shapes. These are not congruent. So dilate with a scale factor of what? Well, let's find out. In this case, let's go from C to C prime. Okay, C, well, would you look at that? These didn't get smaller. This shape got larger. Okay, but from C, those coordinates are over 2, up 2. So for C, my coordinates are 2, 2. I said 2, 2. For C prime, my coordinates are 1, 2, 3, 1, 2, 3, 3, 3. So again, let's follow what we just wrote down here, right? It's new divided by old, except now I'm using my new numbers here, so let's go ahead and erase that. Now I'm using, I'll even use a different color. I'm using 3 is my new number, 2 was the original number, and actually that doesn't matter if I'm using X or Y because it's the same one. But 3 divided by 2 is 1.5 or 1.5. And that's about the origin. All right, last two problems, and then we're done. It says, they give us the shape and they give us the rule. The first one says dilate of 1.5 about the origin. Okay, so that means I'm going to take all my ordered pairs and I'm going to multiply them by the scale factor. If you know the scale factor, I showed you how to find the scale factor, but if you know the scale factor, you just multiply every point by that scale factor. So we know the scale factor is 1.5. Let's start writing out these points. I've got I, J, and K, and then that'll give me I prime, J prime, and K prime, okay? Because I'm going to multiply each of those by 1.5. So for I, it looks like I'm over 1 up 2. So for I, it's 1 comma 2. For J, it's -1 and then up 1. And for K, it's -1 and then down, what do we got? 1, 2. Then down 2. So for my new ordered pairs, for my new points, I have to multiply every single number by 1.5. Well, that's easy because there's so many ones here, because 1 times anything is itself. So 1 for the x value for I prime, 1 times 1.5 is 1.5. 2 times 1.5 is 3. For j prime, -1 times 1.5 is -1.5. 1 times 1.5 is 1.5. And for k prime, -1 times 1.5 again is -1.5, just like for j prime, right? And then -2 times 1.5 is -3. And then just graph those points. Okay, I prime 1.5 or 1.5 comma 3. So 1.5 means you're going to go over 1.5 and then up 3. So 1, 2, 3. Right there would be I prime. Let's go ahead and put a point there. I prime. J prime is -1.5. So left 1.5 and then up 1.5. So 1.5, 1.5. So I'd be right here. That's J prime. And then K prime is left 1.5, down 3, which is right here. And then just connect those points. I'm using the magic of the iPad. Notice all of my sides are parallel. When I do a dilation, all the sides are parallel again. Okay. For number 16, I want to do the same thing. So let's just breeze through this. We know what to do now. It's X, Y, Z. Make sure your fly's up. And then X prime, Y prime, Z prime. Again, I just do the little dash through my Z so you don't think that it's a 2. And it says to dilate by a scale factor of 2.5. So I'm going to get these coordinates and I'm going to multiply every single one of them by 2.5 or by 2.5. Okay. So I've got X is at -2, -1. -2, -1. Y is at 1, 2, 1, 2. 2, 2. Another 2, 2. And then Z is at -2, +1. All right, I get to multiply all of those numbers by 2.5. -2 times 2.5 is -5. -1 times 2.5 is -2.5. Okay. For Y prime, 2 times 2.5 is 5. 2 times 2.5 is 5. So I've got the point 5, 5. And then -2 times 2.5 is -5. 1 times 2.5 is 2.5. And then just graph those new points. X prime is at -5, so that's left 5 and then down 2.5. 1, 2.5 would be right there. That's x prime. Y prime is at 5, 5, over 5, up 5. That's in this corner right here. That's y prime. And then z prime is at negative 5, so that's over to the left all the way, up 2.5. Whoa, up 2.5. 1, 2.5. That's my z prime. And then just connect them. Okay, you can see we'll have parallel sides again. Will help with the magic of the iPad to make that last one look nice and straight. Yeah, that's it for transformations, guys. Hopefully that refreshed your memory on everything that you learned way back in the first quarter. But if not, make sure you ask your teacher for some help.